All right, everybody, so we have a problem here that we're going to work on, and we're going to utilize the quotient rule to solve. So let's first identify what u and what v is. So number one, u is going to be x squared plus 1, and v is going to be x squared minus 1. So before we can begin the problem, you always have to identify what u and v is. So now we can find our derivatives. So therefore, u prime would be 2x, and v prime would also be 2x. Now we're ready to use the form of the quotient rule to properly find this derivative. So let's start with our differential. And I'll write, first it's u prime, which is 2x, times v, u prime v, minus, we'll put a bracket, v prime u, divided by v squared. So now I could just use some basic algebra and distribute. So we get 2x cubed minus 2x minus. Now in this case, I'm going to take the bracket off, and I'm just going to leave a pair of parentheses. So 2x times x squared is 2x cubed plus 2x divided by x squared minus 1 to the quantity squared equals 2x cubed minus 2x minus 2x cubed minus 2x, all of this divided by x squared minus 1, quantity squared. And as you can see, these will cancel out, and you'll be left with minus 4x over x squared minus 1, quantity squared. And you have the correct form. You have the rules broken down according to the proper definition up here, and we simplified our answer all the way. So let's try to do another problem and see if you can apply these same rules. Let's take this off. And let's begin, and let's try to do one with a sine function. So in this case, I'll make f of x equal to sine of kx plus 1, and our denominator sine of kx minus 1. So what would u be? U is sine kx plus 1, and v would be sine of kx minus 1. Then our derivative would be equal to the derivative of sine of kx plus 1. So we have a trig function, and we know we always multiply the derivative of sine by the rate of change of the angle. So we have cosine kx times k, and the derivative of 1 will be 0. Our v prime would be cosine kx again times k. Now, if you'd like, it's helpful to simplify these out a little better and move this k in the front. So k cosine kx, k cosine kx. Now we're ready for our derivative. So let's start with our differential. So f prime of x equals, let's start with u prime, k cosine kx, u prime v minus v prime, which would again be k cosine kx v prime u. All divided by v squared. Now for this problem, we're going to need a little bit more space. So I'm going to move the equal sign over a little bit, and we're going to start our problem over here. So k cosine kx times sine of kx would end up being k cosine kx sine of kx. And k cosine kx times minus 1 would be minus k cosine kx minus. Now I'm going to put a parentheses and I'm going to distribute this one. So we would have k cosine kx times sine kx plus k cosine kx. Close parentheses off. All divided by. Now the nice thing about this, we just leave our denominator alone to the power of 2. Continue, so k cosine kx sine kx minus k cosine kx minus. We're going to distribute k cosine kx sine kx minus k cosine kx divided by sine kx minus 1 squared. Now, let's see if anything cancels. And we already see that this, the k cosine sine kx, this would cancel, and we'd be left with a minus 2 k cosine kx divided by sine kx minus 1 squared. And let's not forget here, we have to have our angle in correctly. Is it in our simplest form? Yes, we've used the quotient rule, stated here. We broke it down and we wrote it all the way out in simplified terms. So here we have 2 examples of problems utilizing the quotient rule. Now let's try another one with an exponential function. Let's say, for example, we have a function we've never seen before. F of x equals e to the x plus e to the minus x divided by e to the x minus e to the minus x. So let's attempt to do this problem and see what happens. So let's first state what u is. So u would be, the derivative of u would be e to the x plus e to the minus x, and v would become e to the x minus e to the minus x. Therefore, we're going to have our u prime, which is the derivative of an e function is itself multiplied by the derivative of the exponent. So e to the x. This is going to be e to the x, but the derivative of minus x is minus 1, so we'll have minus e to the minus x. And v prime would equal e to the x plus e to the minus x. So this is not too bad. F prime of x equals e to the x minus e to the minus x, u prime v minus bracket parentheses v prime e to the x plus e to the minus x u. divided by e to the x minus e to the minus x squared. So we have some simplifying to do here, and we're going to utilize FOIL to do this. So e to the x times e to the x would be e to the 2x. E to the x times minus e to the x would be minus e to the 0. And this is going to end up being minus e to the 0. Because when you multiply same bases, you add exponents. And minus x plus x is 0. Plus e to the minus 2x. Minus parentheses. Here we have e to the 2x plus e to the 0 plus e to the 0 plus e to the minus 2x. All of that divided by this denominator. So let's simplify. E to the 2x minus 1 plus e to the minus 2x. Now let's just go ahead and distribute this. So minus e to the 2x minus 1 minus e to the minus 2x divided by e to the x minus e to the minus x squared. Let's simplify a little bit more if we can. So e to the 2x minus e to the 2x cancels. Plus e to the minus 2x minus e to the minus 2x, that cancels. So we're left with minus 1 is minus 2, minus another 1 is minus 3. We end up with minus 4 over e to the x minus e to the minus x quantity squared. And there we have it, everyone. So let's try a few more and let's see how you're doing.